SwayamPrabha. Digital India. Educated India.
So, in the previous lecture, we had just started the module 2, which is on wood and engineered wood and bamboo. So, in the first lecture, we had started with wood and we had gone for the classification and how do we get wood, what are the stages like getting it from the tree finally to how we use it for our purpose. Here we will go into further details of it, and we have this time procurement details, properties of wood and the classification, not like what are the types of trees, rather what are the different types of timbers commercially classified as. So, types of seasoning we will try to cover, as we knew that seasoning is required very much because it is a natural material and it needs to be seasoned or it has to be weathered, it has to be kept exposed to the weather. So, we will look into the different types of seasoning. Then after getting seasoned wood, we need to know how to convert it to usable form. Then we will go for the different ways of preservation, as this is an organic material mostly comprising of cellulose, which is attacked by termites, white ants and various other organic growths. Then we will just go into the properties of wood and the commercial classification of wood, and we will next move to the lecture 3. So, let us see the types of seasoning. So, seasoning is a long process in which the natural material is kept exposed for a considerable period of time. This we also had seen in our first module when we covered stone. So, here it actually reduces the moisture content because the tree trunk is full of sap and it needs, and also that contains a majority of water. So, it needs to be brought down to around 12 to 15% and make it to usable form. It is a slow gradual process, as because it is naturally happening, free air needs to circulate all around. So, the entire assembly of logs has to be kept apart from the soil, say around 1 feet above, and the logs are arranged in perpendicular and perpendicular direction. So, every layer is in perpendicular direction, kept apart at a distance, so that free air can circulate and it is allowed to stay in the natural weather. So, for sapwood you will see, or softwood you will see, it is taking 2 to 3 months of time, but for hardwood it takes 12 months of time. So, this is a simple way, cheap way, but a slow way. But in this process what happens is the outer part may get more seasoned, whereas the inner part may be full of sap again, or the moisture content again. So, one has to be very careful when they are handling, and when the wood is worked on, that is when any kind of sawing is done, it would be understood if it is rich in moisture content. So, seasoning is necessary and it can be found out whether it is rightly done or not. Next we come to the artificial seasoning. This is a controlled method and there are a series of methods which you can see on the slide. It prevents attacks of organisms. See, in the natural process, when it is lying for 10 to 12 months, then some kind of organic growths may happen which you cannot solve, because there may be rainy season in between. But in this particular artificial seasoning, it is a controlled environment and there you are not allowing the organism to grow. It is much quicker, less time intensive, and wood may lose strength in that case. When it was happening naturally, the fibers were releasing the water in a very gradual way, the fibers were not getting affected. But here, as the water is drawn out artificially or the moisture is drawn out artificially, it may affect the durability, it may lead to cracking, it may lead to warping. Again, the word warping comes. If you remember, during brick we use the word warping, that means deformation. So, the wood may warp or get deformed. So, that can happen when it is artificial seasoning. Under this you see there is water seasoning, boiling or steam spray, clean seasoning, chemical or salt seasoning, and electrical seasoning. You can see in the brackets the time periods are also given, where water seasoning you see it takes 3 to 4 weeks. Here the water logs, the wood logs are allowed to stay in water, and gradually the sap containing the minerals come out is being replaced by natural water. So, the sap which has maximum organic items get diffused to the normal water where it is stagnant water where it is kept, and then again you have to take it out and leave it for dry. Whereas the boiling or steam spray, you see it is a very quick and effective way where you need to allow the logs are put in boiling water, where the boiling water moves through the grains or the fibers, and the sap is being replaced by the water. But this is again an expensive process, because you can understand the sizes of logs of trees are few feet long and even 1 to 2 feet wide, and then you are actually allowing it to get boiled in boiling water. So, the volume of water required to boil etc., you need lot of energy in it. Maybe you are getting the work done in 4 to 5 hours. Next is the clean seasoning. Here actually you can control the temperature, you can control the humidity, you can control the air circulation. So, in the clean these logs are arranged, organized, and then it is controlled drying. So, everything can be controlled, and here there is no external water. What you saw in the other two processes, water seasoning and boiling seasoning, boiling or steam spray, there you are actually allowing the water to enter into to replace the sap, but in clean seasoning the water is being extracted out. So, this also has to be done for specified time. So, depending on the type of wood, whether it is hardwood or sapwood, whether it is softwood or hardwood, you have to do the control. Next you see it is chemical or salt seasoning, where low vapor pressure salt solution absorbs the water or the moisture from the tree trunks, the logs. This helps in the process of seasoning, as this low vapor pressure replaces the moisture, and low vapor pressure allows the moisture to come out. The last one is electrical seasoning. So, wood being a bad conductor resists the flow of current. Sapwoods contains more of moisture. Hardwood is again dense. So, when there is the charge flowing through it, they want to resist the current to flow, which generates heat inside. This heat actually helps in the drying process, and there you get the dry or seasoned timber. You may note that many a time I am telling wood, many a time I am telling you timber. So, timber and wood you can use simultaneously, they have the same meaning. particularly to this particular course, particular to our trade. So, what you understood, natural seasoning and artificial seasoning. Natural seasoning is a slow process, cheap process, simple process. Artificial seasoning needs intervention through water, through chemicals, through heat, through electricity, and lesser amount of time gets involved. You get it faster, but yes, at the cost of strength, durability of the wood. Now we come to the next item. Once the seasoning is done, you need to convert your timber or wood. Now, what is conversion? You cannot handle such big logs, those are not allowed to be used directly, because those sizes, dimensions do not match with our neither furnitures nor door window sections, support sections. So, you need to convert it to sizes appropriate to your use. So, you have to take out the ready wood from this so that it is marketable. This point of conversion was discussed when we discussed the points. Now, you see the first picture, which is ordinary sawing, which is a very schematic section where you see the cuts are directly made tangential to the annual rings. So, what is happening? You are getting timber with varying wood quality from inside to outside, and any defect, if you have any defect inside, all are coming in that section. But what is the beauty of it? You lead to minimum loss of wood. So, you will get wood, a mixture of hardwood as well as sapwood, and thus it will have different moisture content. So, when the moisture content is different, it may have unequal expansion and contraction, and against the annual rings, if you are having any pressure applied here, so if you are nailing here at this point, it may split. So, you have to remember, yes, 100% you are achieving almost 100% wood you are getting, just taking off the barks etc. will lead to, and the central pith or the dry dead part will lead to some eventually 10% loss, but it is not good for high quality woodwork. But yes, you can get a good amount of wood. So, let us look into the next process, that is the tangential sawing. Here also you are following the tangent, but you are trying to get a little more of similar quality wood. So, it is almost at 90 degree you are cutting, you are getting your slices, you are getting your usable slices. So, you can use this similar kind of wood from one cross section between two tangents, you can get this kind of wood. They will be very much similar, and you will have only one or two annual rings passing through it. Yes, that may have some warpage, it may move, expansion may be differential, but yes, you will get you will get better than what you are getting through ordinary sawing. So, this again is a mechanized process. The upper one is also a mechanized process because it is not humanly possible, but yes, skill is required. Here it was allowing the blade to pass through and through. Here you have to pass it after understanding where the annual rings are passing through. So, you will get more or less same type of wood, majority of the portion will be same type of wood, say if this is one section you are getting, you will get majority of it similar kind of wood, and you can use it for little better cause. But remember, in both the cases you are not getting rid of any defect which may be inside the timber or the wood. Let us see what happens next. It is quarter sawing. Here you are dividing the entire log into 4 parts. Here you are dividing the entire log into 4 parts, and then you are cutting at right angles you can see, and getting the pieces. So, this can be done for wood which has no distinct medullary rays, that is mostly for the sapwood, that is pine, mostly for the softwood where no distinct medullary rays are seen, and timber may bend in the transverse direction. Longitudinal means when you are cutting, it is the longitudinal direction, the way it is cut. Transverse direction is it may bend on the breadth side, it may bend because you are having mix of different levels of wood. Next you have the radial sawing. This is considered to be the giving you the best kind of wood. Now why? Because you are considering half of the, you are going or moving radially, you are getting pieces which are, now you are getting pieces which you can actually take it out in this way. So, you can get more or less similar quality wood. You can take out another piece from here like this. You may avoid some defect which may happen here. You can take this big piece and then convert it into your usable pieces. So, you can avoid, say some defect is here, you can take this portion and again take this portion separately. So, what is happening eventually, you may lead to losses, but you will get good quality timber separated out. So, here you see you will get similar kind of wood what you are getting in ordinary sawing, where you are using up the entire of it, but here you are making it as per your wish by sorting it, finding the defects and using that particular portion. Yes, you can do that with ordinary sawing also. And here you get minimum distortion and you can get decorative faces because you get the grains passing through it which can be seen properly. This is having the maximum loss, and here you can avoid the medullary rays. So, the cuts are actually radial and you can follow the medullary rays to avoid the cracked or those lines which are due to the formation of those medullary rays where the things are weak. Now, let us move to the preservation of the timber. Why preservation? As wood is a natural material, we have to avoid growths, its capability of drawing moisture, or with dampness it may lead to growths, and also to make it little more resistant to fire. As you know, wood is flammable. So, what are the different types of preservatives? Chemical salts can preserve. By putting a layer of protective chemical salts, you can preserve timber. If you use large long sections, you can paint it with coal tar. When it is embedded below the ground, you cannot access that portion, and that portion continuously faces groundwater and also the microbes within the soil. So, that can be prevented by the impervious layer of tar. Creosote oil, that is by oil treatment, you can do a preservation of timber mainly to avoid attacks of termite. You can also impregnate or push in or inject in some oils to give preservation from inside, because timber can have growths externally. Being natural, it may have entrapped organisms inside it, which may lead to attacks from inside. So, to prevent that, you can actually apply pressure and inject certain oils. You can also apply paints to make it preserved from termite attacks and moisture decays. How are the applications made? Obviously, painting is one. So, you can paint with help of a brush. You can spray, as you see, it is an arsenic, copper and potassium dichromate mixture, which is called ASCU, which is hydrated, that is mixed with water and is sprayed on top of the wood surface. So, this also prevents the growth of termites and protects it white ants and microbes and helps in preservation of timber. So, spraying is another way. Dipping in solution or in a way applying on top of it is another way where you can dip the entire timber pieces, that is the converted timber, into solutions. So, this is a better way. Why? Because through brushing or through spraying, some portions may not be covered. So, there may be some loose, some non-covered areas which you do not experience when you are dipping entirely in the solution and injecting what I told you, like pressure difference, applying with pressure certain thing through vacuum process. You can inject the oils into the timber so that to avoid any internal defects, internal rots. So, after converting your wood into usable form, you can use it for your purpose. It may be a structural purpose, it may be making a furniture, it may be making a tabletop, it may be for making a partition wall. So, now when you are putting, you have to know what are the properties. You can use it for making a truss, wooden truss. As you have been told, wood acts good in compression as well as tension. You can understand after the physical properties comes the mechanical properties. Under the physical properties, you all know that wood is dark brown or light brown almost in color. We have seen some pictures of it earlier. It is mainly made of cellulose and it is the texture along the grain direction which is giving it an unique look, and this texture actually makes it more appealing. If you preserve it by coating it, hiding the texture, you may lose its value. Density of wood always floats in water, and that is actually the bulk density. With the pores, it is around 0.6. Shrinkage and swelling, yes, it shrinks, it swells by absorbing moisture or giving out moisture, and it may be in the volumetric direction or it may be in the linear direction. So, when it is in the linear direction, it is much lesser in percentage, but in the radial direction, that is if it is a cross section direction, then it is next, but tangentially it is the highest. So, by volume it increases maximum. Heat conductivity, as you all know, timber is very less conductive, rather very good resistant to heat, and it is having a very low conductivity value of 0.1213, which is almost 1/7 or 1/8 that of a brick. But it conducts sound. It is affected by acids but not much by alkalis. So, these are chemical properties. Now, we come to the mechanical property, which we are much concerned because we use wood as a structural member also. As I told you earlier, truss is one such. All our wooden furniture, there you are actually either putting compressive load or you are subjecting it to tension. When it is parallel to the grain, that is along the xylems, the phloems and the xylems, it takes maximum tension of 80 to 190 Newton per centimeter square. In compression in the axial direction, it is 30 to 77 Newton per square millimeter. But you see in the bracket it is written with 15% moisture content. So, we always consider this moisture content as 15% given. Defects of timber. Yes, it reduces the strength particularly on the tension member. So, we have to be very careful when we are using wood as a tension member in truss in form of beams spanning two ends. Some member is spanning two ends. You have to remember minimum defect is the better. Wood is not good at shearing strength at the edges. The values are given. When you are using wood for flooring, not wood paneling, where walls, nowhere when you are using as panels, they are subjected to loads. When you are using wood for flooring, toughness is important. Wood splits, as I already told in the ways of conversion. If you are hitting a nail on annual rings, those positions, the cleavability takes place. Ease of splitting is more at those points. So, it should be looked into that we are putting the nail in the right portion. That is the carpenter's job. When we will discuss joinery in the next lecture, we will see that again. Now, we come to the simple commercial classification of timber, where we see based on produce in our country. This is given by the forest department. We say X grade timber, which is most commonly available. So, produce is more than 1415 cubic meter. So, these are not very recent figures, it may have changed, but yes, it is based on some figure based on the produce. Y grades are the most common, which is of the mid order growth, mid order produce, and Z grade is less common, not much yield. Based on durability, you see highly durable timber, that means it is measured through time, 120 months, that is 10 years. Moderate durable, you see 5 years to 10 years, 60 to 120 months, and low durable is less than 60 months. So, it will rot or decay within 5 years. Again, another classification is based on the modulus of elasticity, that is group A, that is the best quality, group B and the group C. You see, these are the modulus of elasticity in bending, that is the maximum it can take is 12.5 Newton per square millimeter, that is for A grade, A group, and for C group it is within 5 to 10 Newton per square millimeter. So, these are the commercial classifications, and now we can actually summarize telling seasoning makes the wood more durable and workable. Proper conversion methods are to be adopted to get quality timber. One can understand on seeing the cross section how the conversion had been done. Based on this conversion, the price tag is also given. Once usable wood is obtained, it needs preservation by practiced methods, which we have already elaborated, and appropriate use to be made considering the properties and its availability. Availability means the growth or how much it is available. This availability also affects the cost. The conversion method also affects the cost. So, by seeing the cross section you can understand, or an experienced eye can understand what kind of conversion has been done, and based on the availability in the market the price is fixed. Here I again mention wood is purchased in cubic meters or cubic feet. We get the price according to 1 cubic feet of wood, and then we need to convert it to our necessary items that requires the speciality or the workmanship which we call carpentry. So, next lecture will be mostly on the wood joineries which we require. After giving a brief on the defects which one may come across while obtaining this timber and how we can rectify it. So, today we end this lecture here.